The relationship between reaction time, physical activity, and attention in children aged 10 to 12. This presentation is an investigation of a published scientific research article under the exploration of cognitive functioning and physical activity/sports in children. This study investigates how physical activity and fitness influence cognitive performance, specifically reaction time and attention in children aged 10 to 12. Reaction time is a key measure of motor control and cognitive processing, and understanding this relationship with fitness can help inform child development strategies. The aim of the investigation is to examine the relationships between simple and complex reaction time, physical fitness, selective attention, and physical activity levels in children aged 10 to 12 years.
To understand how researchers gathered their data, here's the breakdown of the methodology. The participants were 119 children aged between 10 and 12 years old. They were grouped based on how much physical activity they did per week. Group 1 didn't engage in any physical activity outside of school. Group 2 did 1 to 3 hours, and Group 3 did more than 3 hours of physical activity each week. To assess the reaction time, the researchers used the Fit Light Trainer, which is the device that lights up and records how quickly participants respond to visual cues. This was used to measure both simple reaction time and complex reaction time. Physical fitness was assessed using a range of tests from the Alpha Fitness Battery, which included things like hand grip strength, a jump test, and a 20-meter shuttle run to estimate VO2 max, which measures aerobic fitness. Selective attention was measured using D2 attention test, which looks at how well students can stay focused and ignore distractions. For the procedure, each participant completed all these tests in a controlled setting. Their results were then analyzed using correlation and regression analysis, which helps the researchers figure out whether physical activity, fitness, or attention were related to reaction times, and which factors were the strongest predictors. This design allowed the researchers to explore how physical and cognitive factors were linked to reaction time, which is a key part of motor control and learning in children.
Key findings within the results highlight that Group 3, or children with 3 or more hours of physical activity a week, had faster simple reaction times, also known as SRTs, compared to less active participants in Group 1 and 2. Group 3 also outperformed their peers with complex reaction times, or CRTs. However, as seen in Figure 1, children with 1 to 3 hours of physical activity per week, identified as Group 2, did not show a major advantage over Group 1, who do not partake in any physical activity outside of school, which supports the conclusion that higher physical activity may be needed to improve complex reaction times. The regression analysis found that simple reaction time is anticipated by physical fitness, such as speed and strength, whereas complex reaction time was predicted by aerobic fitness and selective attention. These findings suggest that different aspects of physical fitness contribute to various cognitive functions, with aerobic fitness and attention being particularly important for complex tasks. The results emphasizes that both the quantity and quality of physical activity are crucial for cognitive development in children. While any physical activity may offer benefits, higher levels of physical activity, particularly those that improve aerobic fitness and attention, are associated with better cognitive performance. Aerobic activities for kids can include swimming, dancing, skipping, or yoga. Therefore, promoting increased physical activity among children could be a strategic approach to enhancing their cognitive abilities.
The study provided insights into the relationship between reaction time, cognitive functioning, and physical fitness in children aged 10 to 12. The findings suggested that both physical activity and cognitive factors play significant roles in determining reaction time performance, with physical fitness generally serving as a predictor for reaction time scores. However, complex reaction time was specifically influenced by cognitive functioning, highlighting its importance in tasks requiring more demanding mental control. The study found that children who engaged in more hours of physical activity each week tended to have faster reaction times, both for simple and complex tasks. In addition to physical activity, physical fitness and cognitive functions like attention and concentration were found to relate to reaction time performance. Analysis revealed that simple reaction time was primarily influenced by physical fitness, while complex reaction time was influenced both by physical fitness and cognitive factors. The study highlights the importance of considering specific nature of tasks when interpreting results, as the type of physical activity or skill being measured may influence the relationship between physical fitness and cognitive performance. So the conclusion, overall, the study emphasises the importance of both physical fitness and cognitive development in improving reaction time in children. The results suggested that enhancing attention, concentration and physical fitness could help improve reaction time, which may have broader implications for children's personal and social development. Incorporating physical activity and cognitive training into psychomotor development programs could be an effective strategy to improve reaction time and support overall growth in this age group.
To conclude, the study demonstrated a relationship between the physical and cognitive characteristics of children aged 10 to 12 and their reaction times. Factors such as physical fitness and cognitive abilities were explored as these varied between the individuals. It was found that physical fitness was more closely associated with faster reaction times in simple tasks, while performance in complex tasks was more strongly related to children's cognitive abilities such as attention and concentration.